My name is Alfred Brew, and it is time to engage the phaser.
Now that my esteemed colleague Andy has engaged the phasers, I would like to introduce you to our laser shooting gallery system. My name is Carl Halden, and I did most of the fabrication work for this shooting gallery. What we wanted to do was create a target system or setup that you could move with you to somewhere like maybe a carnival atmosphere or even for personal home use. But instead of needing something that could launch projectiles and encourage possible ricochets and other potentially harmful occurrences, we just wanted to use electricity. What we have is a laser pointer that emits a certain frequency of light that also carries with it an energy. And when it is aimed at a photoresistor, it knocks over the cans rather than, say, a BB gun. What we're using is a case that has been laser cut from a printer available to us at our university and allowed us to take advantage of some of the more complex fabricating systems that we may not normally have access to. So our basic mechanical setup involves two targets that sit on a rotating spindle, which we machined to locate the targets. When the targets are hit, they will rotate themselves about the spindle while the spindle remains fixed until both targets are knocked over, at which point the spindle, which is connected to a stepper motor, will rotate and bring the cans back up. The cans will fall into place, and then the spindle will return to its original zero position. Here's a mechanical demonstration of the phaser engager laser shooting gallery. One of the priorities for Andy and I was to make a clean project that looked good and functioned well. So we weren't really trying to get something that was as complex as we could manage or something that looked really pretty but didn't work. We wanted to combine the two and really exercise our engineering skills as people who could one day develop products. One of the biggest opportunities for us was to take advantage of the school's Epilogue laser engraver slash printing system, which allowed us to not only engrave the logo of our product into our setup, but it also let us make something that could hide all of the circuitry and present the function of our device. So this was a really great opportunity for us to take advantage of learning new hardware and software. And it also turned out to be quite an inspiring effort as future mechatronic projects can involve systems similar to what the laser printer offered us as far as stepper motors and precise positioning, along with other various functions interfacing with laptops, computers, learning about serial communication. So that was a bit of an eye opener within the project as we were working on our project as to future things we could work on. Now we'll cut in some clips of us as we were actually cutting the frames and panels for our project.
A perfect big, one of the live guys who goes to Wednesday live, Eric Haley.
Alright, so Carl Holden kind of went over the actual design of the project here. I'm going to show you kind of the inner workings of the project, and that involves the circuit. So as you can see here, we got a platform right here. And what this platform serves to do is to protect the actual circuit, all the wires itself underneath. Now, one of our problems that we ran into was the actual tension in the wires here would be enough to pull the cans back itself, and that would really mess up our system. So this kind of protective platform that we built not only protects our circuit, but it kind of helps to alleviate some of the tension that we found in our cans. and inner wires. So one of the aspects that we're very proud of is that this project can be run entirely upon one source here. So as you notice right here, we have a jack here that connects to any wall socket you can find in your house. And this supplies 24 volts of DC to the entire system. Now that 24 volts is going to run along this red voltage bus line right here. And these 24 volts help power the 2 solenoids that are used to knock over the can. However, 24 volts is too much for the Arduino to handle, and it's too much for our motor to handle. So to deal with that, we have 2 step-down transformers. So we have this guy turning from 24 volts to 5 volts, which will power the Arduino, as well as supplying voltage to the photoresistor so we can measure the photoresistors. And we have 24 volts changing into 12 volts that is used to power our stepper motor. And again, it all connects back into one simple jack, so you can just plug it into any wall. Okay, so right here we have our Arduino connected separately off from the actual solderless breadboard that we have used. It's getting its 5 volts from this jack right here from the 5 volt bus line. And in the analog pins, we've connected the photoresistor, so these guys are doing a constant analog read of the ambient light going around. And when it's hit by a very high intensity light source, in this case our laser, the photoresistors then return that value to the Arduino. So upon receiving the analog value from the photoresistors, that is now fed to the Arduino, and then we decide to switch on the solenoid. So the 2 solenoids are connected by these 2 yellow jumper wires connected to digital pins D2 and D4. So these guys are connected to these 2 transistors. Now you'll notice these are very high level transistors, and that is because in our original design we used transistors that barely fit our requirements. So make a long story short, we blew up our transistors. So to help deal with that, we got these 2 giant transistors that can handle 60 volts, 3 amps, and they can handle very high temperature. So there's no worries in these 2 transistors burning out. Okay, so as you can see here, we have 2 solenoids. Now you'll notice that when these 2 guys are fired, 2 plungers will come up, and that is what knocks over the cans. Now we have programmed it so once both of these solenoids have fired, the stepper motor will in turn rotate a certain number of steps to return the cans to the original position. So you can see 1 plunger there, you can see the other plunger there, and now they'll both go off, returning the cans. So right here we have our stepper motor connected to a dual H-bridge system, which is being powered by the Arduino here. We have used some heat shrink wires to try and keep some of the wires looking a little nice, a little more friendly looking. And they're connected right here to pins D6 and then D9 through 11. So now we're going to show you a quick clip of our entire circuit, just bare bones, and our first time testing it all out.
You didn't get the other one.
Here we go.
Boop, 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 boop. Sick. Go.
Alright, so sensor 1, sensor 2, motor drives it, all one plug.
Do it again.